All right, new day, new laptop to repair. This time we have a Dell gaming laptop. It's a G15 5515, the Ryzen edition. The customer said they smelled a burning smell and it went black and won't power on. So let's see if we can get this fixed up. All right, let's see if it powers on here. Got nothing. Power button feels weird. Doesn't feel as clicky, but I don't think that's the issue. This laptop takes a 7.4 millimeter Dell jack. Oh, it shorted out the adapter. So if you noticed here, my power meter went out. So right here is my Dell power meter. And what I do is I have a Dell DC jack and it plugs into the back of this. And then it will display how much current is actually being pulled from the AC adapter. And immediately whenever I plugged in the jack into the back of the laptop, it put the charger in protection mode, which shut it off for safety. So this means that this laptop has an internal short. That's what's causing this issue here. And since there was a burning smell, I'm assuming there's some sort of burnt component here. Let's go ahead and get this laptop opened up. Oh, looks like I noticed that there's a crack here. I see a crack here where the speaker is. That shouldn't be a big issue or anything, but it might have been when they were trying to pry open the bottom. I could tell these screws have been taken out before. I see a mixture of screws here, so these aren't even the right screws that go here. All right, and the bottom is open. Let's see if we can identify a few things here. So here's the battery. It's a genuine Dell. You can see the serial number here. Here's the M.2 hard drive. We have a couple memory sticks, the Wi-Fi card. Here's another hard drive right here. It's a 2280 hard drive, full size. And got a couple fans here. I actually can see an issue right here. Let's go ahead and get this under the microscope so you can take a closer look. So I can physically see that there's a burnt component right here. And this is part of the input circuit. All right, if we're looking right here, so let's follow the path real quick. All right, so this is the DC jack right here. This is where the power comes in from the charger, from the DC jack. Comes in through here, it goes in through this pair of MOSFETs right here. Then it goes through these pair of MOSFETs. This is the protection MOSFETs that will protect the board in case there's a short somewhere. Then that comes over here to the main power rail, and this is the current sense resistor for the main power rail. And this MOSFET has obviously exploded. Now, I suspect that this isn't the cause, but it's a symptom. I assume that actually something else is shorted out somewhere else on the board, and this little MOSFET right here has been protecting the laptop. So, and you can see these have been getting hot here too. Let's take a look. So this is very, very hot. It's been melted. I'm gonna go ahead and remove these and set them aside. We'll put them back on later. Okay, so let's go ahead and measure the main power rail. I'm gonna put the voltage meter in continuity mode. When I touch the probes together, they beep. And I'll put one side on ground and one side on the current sense resistor for the main power rail. And you can see there's a short here. But let's go back over here to the DC jack and let's see if we have a short on the DC jack. This side's ground, this is the positive side. So there's no short here. Let's see on the other side. No short here, and then on the output of this, we have a short. So these right here are actually shutting off the current flow. But whenever we first plug in the AC adapter, it sends the voltage through those, trying to turn on the main power rail, and then finds that there's a short, and then it shuts them off. And so basically this will it shorts out the AC adapter, and the AC adapter, since it's a genuine Dell AC adapter, it puts itself in protection mode and shuts itself off. So all of this is made to protect the motherboard from getting further damage. So we're gonna have to start out by actually taking off this burnt MOSFET here to figure out if there's an issue on the other side of this MOSFET or if it is this MOSFET. This is a MOSFET like this is it only acts as a switch. So it has 3 legs on one side, 4 legs on the other, and then a pin that basically turns on the flow or turns off the flow. That's it. So it's acting as just a switch. So there's really no way for this to be shorted to ground. So most likely there's going to be a short on the other side of this on one of these power rails. And because this is a gaming laptop, I wouldn't be surprised if it was actually like the GPU or CPU that's actually causing this issue. But let's start out by taking this off here. So we'll go ahead and use some hot air and we'll get it taken off. All right, we're going to put a little bit of flux on here. And a chip that's actually this burnt is actually, it's most likely welded straight to the board because it gets so hot that it fuses the metals together. So we're going to have a hard time getting this off, and I'm going to do my best to get it off without actually pulling the layers of the board off, but we should be all right. It's just going to be a pain. We're going to do this at 460 degrees at 60% air. We'll start with that and see if we can get this chip off. All right, I'm slowly heating the area. This will take a long time. This is actually a really thick board. When these are gaming laptops, are really thick. It's going to take a little bit of time. And because it's welded, most likely I'm going to be very careful trying to lift it up. And I'm actually prying underneath just a little bit. I bet we're going to break this chip into pieces. I'm not that worried. Okay, here we go. Yep, it's coming up. All right, and so we got the chip off. And it actually came off in one piece. I'm actually very surprised. So there it is, burned up. But you can see that you can see the pad right here lifted up. But we're okay. It's still intact. We're going to get this area cleaned up right here, and then we'll continue measuring. We're trying to figure out if there's still a short somewhere in here. Pretty sure that the short's going to be gone at this point, but I bet the short will be here. So, but we'll figure that out in a second. All right, I'm just going to try to clean up this area a little bit. I'm pretty surprised. It's not too bad. Okay, let's test this. Turn off the air. Okay, we're still having continuity mode. We're just going to see if the short is gone. Okay, probe on ground. And the short is gone on the main power rail, on the current sense resistor. So right here it's gone. Is there a short right here? We have a short. Okay. So at this point, we know that there's a short on the other side of the main power rail. So we don't know where the short is at this point or what's causing that short. So what I'm going to do is we're going to go ahead and pull this board out, and then we can do some voltage injection and figure out where it is. Or there may be another burnt chip somewhere that we can see, but we're going to have to pull this board out. Oh my goodness. Okay. Before we proceed, oh my gosh, look at this. Do you see this? This was burning hot at some point, and it almost melted the bottom here. So we'll have to make sure that this DC jack is actually good. All right, and the motherboard is out. So let's go ahead and see if we can figure out where that short is that's causing this motherboard not to turn on. We'll have to pull off the heatsink too. It's going to need to be re-thermal paste anyway, since we have it here. Okay. All right. Thermal paste doesn't look too bad. It looks dried up, but it is original. The fans don't look too clogged, so that's not too bad. Okay, so let's do a physical inspection. We're going to go around with a microscope and see if we see anything obvious first. So let's start out over here. It's pretty dusty. So what we're looking for is any broken chips, burnt chips, anything that's discolored, anything that, if there's water damage, any water damage, any broken chips, any burnt chips. This is what we're looking for. We can go ahead and take this off too. We'll put it back on at the end. Just a lot of dust. I don't see anything obvious so far. So here is the GPU. Looks like an NVIDIA chip of some sort. I don't know which one it is, but we can look that up. Here's the Ryzen 7 CPU. All right, and this is going to be a little discolored because there's a heatsink that presses down on here, so that's pretty normal. So all of these are the DR MOSFETs. It's going to be a MOSFET driver and dual MOSFET package all built in one that drive all these power stages. So one of these could be shorted out. This is flux, that looks okay. It's fine. So I don't see anything on this side. Let's go ahead and flip it over. Okay, so let's finish looking around. Here's the chip that was shorted out, or that was burnt up, and it was probably shorted straight to it. But remember, the short's on this side, there's no short on this side now, so none of this is shorted out anymore. It's all gonna be on this side, in this circuit here. But we're just gonna look over here. Here's the LCD connector. Looks okay. All right, so we're not seeing anything. So we're gonna have to go to voltage injection. So how voltage injection works is that we inject a low voltage, and any component that's shorted out to ground will start heating up. And so we're gonna put that under our thermal camera, and it will reveal the chip that's actually having the issue. So let's go ahead and get the thermal camera fired up. All right, we got it down here in the corner. And so we're gonna use my short killer, which I always say this, but I don't really recommend the short killer because you can't limit the amount of amps you're putting in there, and you don't want to damage anything. So here's how I use the short killer. What I like about it is it beeps. Let me turn it on real quick. So it starts out at 1.5 volts. We're gonna inject 0.8 volts. We're not gonna hurt anything at 0.8 volts. But if I short out these two leads, we get the full amps in there. Now, most likely any component that's shorted out on here is not gonna be taking that much. It's probably gonna take an amp 2 or 3 at most. And so that's what we're gonna be looking for. So especially whenever we're doing 0.8 volts. When we're at 0.8 volts and it's at 3 amps, we're not using that. There's not a lot of watts going on. So I'm not worried about burning out the GPU or anything like that. That will usually survive, not a big deal. Now, the GPU could be already damaged because whenever you plug in your charger and it shuts off the charger, it's sending that full 20 volts straight to whatever shorted out. And then the machine, the current sense resistor sees that there's all this current going through the board and says, hey, no, shut it off, shut it off. So that's, the GPU could already be toast, or CPU, or whatever it is that's shorted. So, but we're gonna start out by doing this. We're gonna put one lead on ground, and we're going to inject voltage at that point that we know is shorted. And then we're gonna look for what will heat up. So this side, oh, 12, ooh, okay. All right, so I'm gonna lower this voltage down. Okay, we're at half a volt here, or not even, yeah, half a volt. All right, so we'll start out on this side. We got nothing. When we do this, we get nothing, right? When we go on this side, we're getting 8 amps. And let's see if we can see anything getting hot here. Okay, I see this getting hot. And I guarantee that when this motherboard was trying to protect itself, it ended up shorting out this. This side right here is connected to the ground, so this is ground right here, and this is a low side MOSFET. So I guarantee that this MOSFET shorted out, and this will just need to be replaced, and then this short will be gone. So let's go ahead and I'm going to go ahead and remove this. We'll replace this with a new one, and then we'll continue testing. Well, here we can measure it since we're looking at it. So let's go ahead and measure across this one. So here's our probes here. This should be shorted out. See, it's shorted out. So this should not be shorted out, but this is acting as almost like a wire, and that's why it's pulling so many amps, because this side right here is ground. See? And so if this is ground, and then this right here is where we're injecting voltage here, which goes through this coil, and this is only supposed to switch on and off to ground. It's not supposed to stay locked on ground. So this MOSFET was completely shorted out and burned up. This MOSFET was completely shorted out. And it could have been that this thing just burned up and got shorted to ground, and then all the voltage came through here and blew that one up. I don't know. So we're going to figure this out. Let's go ahead and get this one removed and replaced, and then we'll continue testing, all right? A little bit of flux. This is my Amtech flux. I actually get this from Northridge Fix. He has a YouTube channel that and puts out great content too. So you guys should check that out if you haven't seen it. Okay, and the chip is out. Let's go ahead and test it. So here's how to test a MOSFET. Okay. So if I just put this in continuity mode, right, I touch my two leads together. So 3 of these are going to be together. So this one's showing all shorted, every single pin's shorted, so we know this one's bad. Let me grab a good one, and then I'll show you how that one works. All right, I'm not sure if this is a good one or not. Let me check real quick. Okay, so we got a good one here. So in continuity mode, it's kind of hard to test this in continuity mode. So see, again, if it's shorted, it would beep. And why not? It's not shorted. So none of these are working. But in order to test this, we're going to put the voltmeter in diode mode. Okay, so now we got a red probe and a black probe, and that's what you got to pay attention to. So if I put the black on here and the touch here, we get a beep. And all 3 of these should beep just the same. That's fine. Okay, so now the moment that I touch this one, it does nothing. But now when I come back here, it's going to be shorted. So what we did is by applying this voltage on this pin, this is the gate pin, now this gate pin has flipped and has turned on the MOSFET, and now it's stuck shorted. So people will think, oh no, this thing's shorted. It's not shorted. If I want to turn it back off, I'm going to put positive here. I'm going to touch this pin, touched, and now I come back over here, and now it's back to working again. So this is how you test to see if a MOSFET is working properly. All right, let's get this MOSFET replaced. Actually, let's test to see if there's a short. Let's see if that short is gone. I suspect the short is actually gone. Let's go ahead and check that real quick. So we'll put it back in continuity mode where it beeps. We'll test here. There's no short anymore. So this was shorted to ground, and it probably was part of the protection, but we're going to go ahead and we'll get this one replaced, and then we'll finish testing, and then we'll replace this one, and hopefully everything will be fixed up. Hopefully there's no other shorts on this system. Press down. All right, and it is soldered. Let's go ahead and clean it up, and then let's check to see if we have a short. We shouldn't have a short because this is a good chip. We're in continuity mode. Let's go ahead and measure right here. We got no short. See? Okay, so the short is gone here. So I do not suspect there's another short on the board. I'm going to go ahead and replace this MOSFET right here. Okay, we have the DC jack. I'm going to go ahead and plug that in. We're going to test to see if this board is still shorting. Keep an eye on the Dell power meter. What we want to see is if it starts pulling current, like it's booting up, or if it shorts out the AC adapter and shuts itself off again. Let's see. We got 0.02. And actually in Alienwares, they don't turn on automatically. So let's go ahead and trigger the power button, which is going to be right here. Okay, so this is what we're going to use to trigger the laptop on. So I want you to keep an eye on the power meter here, the Dell power box. And whenever I short out this pin, I'm going to short this pin to this pin, and the laptop should come on. Look at that. Look at 0.38. Let's see if it jumps up higher. 0.4. It should jump to 1 amp or more. We don't have a heatsink on here, so we're just going to pay attention to how many amps are being pulled. 0.4 amps is not that bad, but it should be going higher than that if it's actually turning on. All right, let me unplug this. We don't have memory in here, so let's put some memory. Okay, we have memory in here. I'm going to plug in the DC jack. Keep an eye on the power meter here. Let's go ahead and short the power button again. 0.46, 63, 1.65. It's powering on. It's going through a posting cycle. We don't have a heatsink on, so we're going to unplug it. Let's go ahead and get it reassembled and test. All right, so I'm just quickly assembling this so we can test. We just want to see if we get a Dell screen. And then we'll have to do a more thorough test to make sure that there's no issue with the GPU or CPU. All right, the motherboard's installed. Let's go ahead and do our test here. Keep an eye on the power meter. Okay, let's get it plugged in. Okay, it's coming on. Look, you can see it pulling 1.91 amps. So right now it's going to go through the startup process. It hasn't, because it's the CMOS battery, the main battery's been unplugged, so it's going to have to do a little startup process, so that will take a little bit of time. We're at 4 amps now, and it's off. See if it comes back on by itself. All right, 0.82, 7.7. Look at that, we got a Dell screen. Perfect. All right, so what I'll have to do is I'll have to continue, I'll have to reassemble this all the way. We'll run stress tests on the GPU, the CPU, I'll run full diagnostics, and we'll make sure everything works. The last thing that I really want to check here before I do all that is we want to make sure the battery charges, because a lot of times when we have an issue like that, it will mess up the MOSFETs that send the voltage to the battery. So let's go ahead and plug the battery in, and I will plug in the battery. And we don't even need to turn the machine on to test this. We're just trying to figure out if we see amps start flowing into the battery. So I'm plugging that in. We're going to keep an eye on the meter. It should jump up to 20 milliamps. And it's just sitting there. So let's go ahead and turn it on and test it then. The battery may be all the way dead. So let's turn it on, go into the BIOS. Okay, it's not going to show me on here. Let's go ahead and let's boot into diagnostics. If we boot into diagnostics, I can actually view all the battery information. Okay, battery currently charged at 100%, and that's why it's not charging. So we'll have to see if it runs off the battery, we'll run it down a little bit, and then we'll charge it back up. So now it's running off the battery, it's discharging, it's running just fine. Now that we confirmed that the laptop's working, we're gonna go ahead and replace this DC jack. I did see that there was some melt here, and there is it's broken on the edge here. So we'll go ahead and get a new one of those installed. I think I have some of those in stock. All right, and I do have new Ryzen Edition DC jacks. These are a Dell OEM DC jacks. So we'll go ahead and get a new one of those installed. And let's boot the Windows. All right, look at that. Got it booted up. So I'll come back after I run all the diagnostics and give you an update on that. All right, doing some final testing on this G15, 5515. Running firmware stress tests. Right now it's running off the battery. We'll go ahead and plug in the charger. It's running at 26 frames per second. It has a 3060. And our charger just shut off. So we have another issue going on, and so we'll have to open it back up and figure this out. And so this is what I wanted to look into here is that whenever one of these main MOSFETs on the main power rails short out, it can short out the MOSFET that charges the battery, sending the full 20 volts to the battery, and then that will short the charger also. Let me go ahead and get this shut down, and we'll get it pulled apart again. So a good test on this is the first thing I'll try just unhooking the battery and plugging in the charger and see if it runs on the charger without the battery plugged in. Then it's most likely a MOSFET that sends the voltage to the battery to charge the battery that's shorted out. And so we'll just have to figure out which one that is and get it replaced. Okay, and the bottom is open. All right, so here's what we're gonna do. Let me turn this around. So we're gonna unplug the main battery here. Okay, so that's not hooked up in there anymore. Let me reset the charger. So we'll just unplug the charger for a couple seconds, plug it back in, it will reset. All right, so the charger is reset. Let's go ahead and plug it in. I'm using the customer's charger too. So we'll plug it in and see if it shorts out. Okay, and so as you can see, it's not shorting out. So the short, it's gone on the motherboard, and it can run off the battery. So we have those two parts working, but when we plug in the battery, it's most likely going to short out. So let's plug in the battery here. I'm going to unplug the charger. We'll plug the battery back in. Okay, now we're going to plug the charger back in while the battery is attached and see what happens. And it went to 6 amps and then shut off. So we definitely have a short on one of these charge MOSFETs. So let's take a look and see if we can figure out which one it is. Let's go to the microscope. Okay, so here's the battery connector. Okay, so this is positive. These 3 pads right here are positive. These 4 are negative. So positive, and then we don't know where this is going, but we can trace it back over here. It's going to go to one of these MOSFETs over here. Got 11.28 there, 11.28 here. So the way that these batteries charge is usually you have a MOSFET that has the main power rail coming from the charger at 19 volts on one side, and then on the other side will be battery voltage, and then the power management chip, which is right here, will control the flow of the voltage. So I don't know which one of these are the 2 we switched out. We changed this one out. This was the burnt one. And this is the one that was shorted to ground here. We changed that one out. So this one is the only other one we haven't switched out. And there may be one on the other side that we've had to pull the board out again. But let's go ahead and get some measurements here. So what I'm going to do is I'm going to unplug the battery again. We'll reset the charger and we'll plug it back in. And so what we're trying to measure for is we're trying to figure out where the 19 volts is going, and if it's going all the way to the battery connector here. So I'm going to put my positive probe on the battery connector, and I'm going to plug in the charger. And this should never go above battery voltage, which is 12.6. And what are we getting? We're getting 19.49. So you see that it's sending the entire charger voltage through here and to the battery connector. And that's why the charger is shorting out to shut off. And so this actually may be why these MOSFETs burned up. It's because it kept trying to prevent this from happening. Voltmeter in continuity mode. And let's measure across these. And this thing is shorted all the way across too. So we're going to need to replace this MOSFET also. This is acting as a wire. So right now the charger voltage is coming through here and going straight to the battery connector. So once we take this chip off, we should no longer see the 20 volts going to this connector right here. So let's get this removed. MOSFET's out. So let's go ahead and test to see if we're getting 19 volts to the charger connector anymore. So we'll plug in the AC adapter, and then we'll measure voltage on the battery connector again. And we're still getting 19 volts. So where is that coming from? Got 19 here, 19 here. Let's go ahead and test this one. I bet this one is not shorted, the one we just removed, and it is not shorted. So as you can see, this was a false positive, but we are on the right track. So we're gonna have to pull this board back out again, which we've already put it back in, but we're gonna pull it out again. All right, and the motherboard is out for the second time. So now we're back to the drawing board trying to figure out why that area is shorted out and why it's sending the full 19 volts to the battery connector here. So we're gonna go through and measure each one of these MOSFETs just one by one and figure out what's going on. We got a short across these. That's what it is. Oh, right. Okay, so the first protection MOSFETs, these actually take a brunt of the force too. So one of these is burned out. So let's go ahead and get these removed and figure out which one of these is shorted. We'll take one off and then measure and take the other one off and measure. We have to slowly work our way through all these different issues. Because you see the main power rail's not shorted. We're not having any issues powering on. It runs on battery just fine. It runs on AC adapter just fine. But when you put them together, it shorts out the adapter. So we've identified that one of these are shorted. We won't know until we take one off. So let's take one off, and if that one's not shorted, then it's going to be the other one that's the issue. Got that one off. Let's go ahead and test, see if we still have a short in that area. All right, let's test across here again. And the short is gone. So So we're not getting a short across here anymore. Let's go ahead and plug in the charger and measure at the battery connector. Charger plugged in. So measure at the battery connector, and we're getting 20 volts still. When we have 19 volts going straight to the battery like this, we still don't know what the cause is. This was the chip that was burned up originally, and now this chip that I replaced is actually shorted out again. We had this chip right here was partially shorted, and so at first it was shorted while it was in line on the board. Then when I tested it, it wasn't shorted. Then whenever I activated it, it's shorted again, and now it's stuck shorted. So I'm going to replace this chip here. This chip I'm going to pull off, and we're going to see, because this is the voltage coming in from the charger here, and it powers the main power rail. This is the current sense resistor on the main power rail. And then after that, it goes through here, and then this is the coil for the charging IC for the battery. And because this is shorted, this should actually be reducing the voltage down to charge voltage, but it's stuck shorted. So we're going to go ahead and pull this chip back off again and see if we get anything different. Now we got to figure out why it keeps burning out. Now that we have this MOSFET taken off, let's go ahead and test again. We have the voltmeter in continuity mode. So if we measure across here, we should get nothing, no beeps, which is perfect. And if we measure to here, we should get nothing. But from here to here should be short, that's correct. So this MOSFET that we replaced already shorted out. Now I don't know why. This MOSFET was also shorted out, and then our MOSFET coming, these work in a pair, so that's why I haven't replaced it yet, because the voltage will still come through this one. But this one was completely shorted out. And now these just act as switches. They're not reducing voltage or anything, so you have the full 19 volts should come right through here, or 19.5, whatever the charger voltage is, should come right through here. So all these gates are going to be hooked together. This gate, and this gate, this gate, and this gate. And so they're not reducing any voltage. All they're doing is acting as kind of a protection circuit that blocks any unwanted current in case it detects something that is going to damage the machine. It will shut it off. Well, with that MOSFET shorted out, it will have a hard time shutting things off. But I've seen these MOSFETs fail whenever there's a short later on down the further down the circuit. So this is the chip that was burned up. We replaced it, it burned up again. But we don't know if it's because this one was already burned up, or if this is what's causing that one, or if this one is actually fine. I need to put this one back on. This is the other one we replaced. So what we're going to do is we're going to put new ones. We're going to replace all of these with brand new ones, and then we'll test again. Got the first one back on. So this one, there was nothing wrong with it, but I went ahead and replaced it anyway. We're going to go ahead and replace this one now. Okay, so we got those two replaced with new ones. Let's go ahead and test real quick, figure out what we're getting. Check our voltages, make sure we don't have any shorts anywhere. We'll replace this one last, which is the one that's was burned when we opened up the laptop, and we've replaced it and it burned up again since. So let's go ahead and figure out what we're getting now. So I have it in continuity mode. We'll test across here. So we have no short across there. These are in parallel. These two are in parallel, so there's no short there. We'll check a short to ground. So we got ground. On the main power rail, no short. And then this is the one that burned up. We have no short across here. All right, let's go ahead and plug it in. Without this one on here, I'm going to figure out if we're getting any voltage here, which we shouldn't, because this MOSFET's off and this is part of the charge circuit, but there may be something else going on that I don't have the schematic for this machine, so I'm just kind of figuring it out as I go. So I'm going to hold my probe on here. We have it on voltage mode. I'm going to plug it in, and we'll just watch the voltmeter. See if it jumps up. It does not jump up at all. Let's go ahead and measure here. We should have 19 here. So on this one, we have nothing. On the output over here, we got 19. Okay, so this is the one that gives it the flow. See, you have to kind of figure this stuff out as you go. So let's go ahead and replace this and see if this chip burns out again. And we have a brand new MOSFET to put there. Let's go ahead and get that installed. All right, so that MOSFET's installed. Now we're gonna have to keep an eye on this. We do not want it to short out again, and if that MOSFET shorts out again, we need to figure out what's going on and what's causing that issue, because that's 2 times it has blown itself out. Now these MOSFETs are almost acting as fuses or a way to protect the laptop from further damage. So we can't get mad at the MOSFET per se. They are switches, and if it is blowing up, that's good. It's protecting other things. So let's plug in the AC adapter. First, I'm just gonna put my probe on the battery connector again while I plug it in, because I want to see if that spikes up to 19 for a second, or if it goes up to 19 at all. It went to 13.25. This is the correct voltage, battery voltage here. So we're looking good so far. There's a chance that that MOSFET will burn back out again. It may have just been because there was another MOSFET that I hadn't found yet that was shorted out that actually caused the other ones to fail. But at this point, we've replaced 3 different MOSFETs, 3 different shorts, and I don't know which one was the actual cause. So we're gonna go ahead and plug in this battery real quick. All right, battery is connected. So let's go ahead and watch the charge current here. I'm plugging it in. 0.01, and what we're looking for is it will jump up to 0.2 and then should jump to an amp or 2. Let's measure the voltage at the battery connector. 12.42. Oh, we jumped up to 1.33, and then we'll watch the voltage go up on the battery. If you look here, I'm measuring the battery voltage 12.43, 12.44. So the battery voltage is going up. So we are charging the battery. The MOSFETs are working correctly. Let's go ahead and get this reassembled and finish our testing. And sometimes this is the way it goes. It's not always straightforward. Just because you see a burnt component, replacing that doesn't mean it will just fix it. And so I'm showing you what a real repair is like. Okay, here we go. We're gonna plug it in. See if it starts charging the battery. That's what we're waiting for. 0.05, it should jump up to 0.2, and then it should go up to 1.5 amps or 1.3 amps. There we go, we're at 1.3 amps. Let's go ahead and turn it on. Pulling 2 amps, pulling 3 amps, looking good. All right, so the charger is pulling 5.5 amps, 4 amps. We have the 3060 running right now, a GPU stress test. When it's plugged in, we're at 102 frames per second with this 3060, and when we unplug it, it goes down to 26 frames per second. All right, so this just shows that if you just see something obvious like that, it doesn't mean that that's the only thing wrong. This MOSFET was burned up, but it ended up causing issues to either side of that. The power coming through the main charger ended up burning out one of the MOSFETs there, and then the MOSFET on the low side of the charge circuit ended up burning up too. So, all right, so this laptop is fixed up and ready to get back to our customer.
I saved another laptop!